In today's class, we'll be doing some more problems on state space theory. Obtain the time response. Obtain the time response for the following system. For the following system. For the following system. x1 dot x2 dot is equal to 1011 x1 x2 plus 01 into u with x bar 0 is equal to 10. A standard examination problem. A standard examination problem. This is A matrix. This is B matrix. So A matrix I will write down here. A is equal to 1011. B is equal to 01. X bar 0 is equal to 10. Step 1 to find phi of t. To find phi of t. See, recall phi of t is equal to Laplace inverse of Si minus A inverse. Laplace inverse of Si minus A inverse. Consider Si minus A equal to S. What is I? 1001. A matrix is 1011. So this becomes S00S minus 1011. This implies Si minus A is equal to S minus 1 0 minus 1 S minus 1. This is Si minus A. Next what we have to do? We have to find inverse of Si minus A means we have to find the adjoint. Adjoint of Si minus A is equal to adjoint of Si minus A is transpose of the cofactored matrix. Of matrix means this matrix. The cofactors of this matrix are S minus 1, S minus 1. This is 1, 0 transpose. So transposition means first row becomes first column. Second row becomes second column. 0, S minus 1. What is determinant of Si minus A? Determinant of Si minus A is determinant of S minus 1 0 minus 1 S minus 1, which is nothing but S minus 1 whole square. Hence phi of S is equal to Si minus A inverse. Si minus A inverse equals adjoint of Si minus A divided by determinant of Si minus A. What is adjoint? Adjoint is s minus 1, 0, 0, s minus 1. The mistake. Interchange these two. This is 1. This is the adjoint. I have made a mistake. We have cofactor of s minus 1 is s minus 1. Cofactor of this 1 is minus 0. Cofactor of 0 is minus 1. Minus 1. Cofactor of s minus 1 is s minus 1. This is minus. Divided by determinant of s minus 1 whole square. Sorry. Let me repeat. Si minus a is this. Cofactor of s minus 1 is s minus 1. Cofactor of 0 is minus of minus 1 means plus 1. Correct? Cofactor of minus 1 is 0. Cofactor of s minus 1. So this is plus 1. This is plus 1. Now divide each element by s minus 1 whole square. So what you get? You get 1 over s minus 1, 0, 1 over s minus 1 whole square, 1 over s minus 1. This is phi of s matrix. What is e to the power 8a? E to the power 8 is inverse Laplace of phi of s. Hence, phi of t is equal to Laplace inverse of phi of s. This is phi of s. So inverse of this is what? Inverse is e to the power t 0. Inverse of this element is t into e to the power t. Verification. Before verification, please note Laplace inverse of 1 over s minus a equals e to the power at. Second one, Laplace inverse of 1 over s minus a whole square equals t into e to the power at. These two formulae have been used to find inverse Laplace transform of these elements. Verification. Phi of 0, you put t equal to 0 here, e to the power 0 is 1, this becomes 0, e to the power 0 is 1 is equal to I. Therefore, phi of t is correct. So for my reference, I'll write phi of s here. Phi of s is 1 over s minus 1, 0, 1 over s minus 1 whole square, 1 over s minus 1. So, phi of t we have found. Second step. Homogeneous solution is x. Homogeneous solution is x n of t. X n of t is equal to phi of t into x bar of 0. Phi of t is what? I use the suffix n because homogeneous solution is also called natural solution. Phi of t is e to the power t 0, t e to the power t. Multiply this by 1 0. So if you multiply, you get e to the power t into 1 is e to the power t. 0 into 0 is 0. T into e to the power t gets multiplied by 1. E to the power t gets multiplied by 0. This is homogeneous solution. Fourth solution is what? x f of t is equal to Laplace inverse of phi of s into b into u of s. In the problem statement, you add, take u of t as the take u of t is equal to unit step function. Take u of t is equal to unit step function. This statement to add in the problem statement. Since u of t is equal to 1 for t greater than 0, 0 for t less than 0, it implies u of s is equal to 1 by s. U of t is equal to 1 by s. Hence, phi of s into b into u of s is equal to, what is phi of s? Phi of s is 1 over s minus 1, 0, 1 over s minus 1 whole square, 1 over s minus 1. B matrix is 0, 1 multiplied by u of s. U of s is 1 by s. So multiply this into this is 0, this into this is 0, so this is 0, this into this is 0, this into this is 1 over s minus 1, this into this plus this into this is this into this plus this into this is this, 1 over s minus 1 multiplied by 1 by s. So you get 0, 1 by s into s minus 1. This implies phi of s into b into u of s is equal to 0. By partial fraction theory, write this as 1 by s minus 1 by s minus 1 minus 1 by s. I have done partial fraction expansion on this. Take LCM, you get the denominator, s comes here, minus of s minus 1 gives you this. I have done that by inspection. Hence, forced response x f of t is equal to 0. This is e to the power t minus 1. Laplace inverse of 1 by s is 1. E to the power t minus 1. Poster. Time response is x bar of t, I put here bar because xn of t is a column matrix, here also I put a bar. X bar of t is equal to xn bar of t plus xf bar of t. Bar indicates it's a column matrix. In the textbook we don't put this underscore or bar, we write it a bold letter. This implies x1 of t, x2 of t is equal to xn of t is what? E to the power t e to the power t plus xf of t is what? 0 minus 1 plus e to the power t. Add e to the power t plus 0, t e to the power t minus 1 plus e to the power t. Hence, x1 of t is equal to e to the power t and x2 of t is equal to minus 1 plus e to the power t plus t into e to the power t. This is the answer. Next problem. Two solutions of the state equation, two solutions of the state equation, x bar dot is equal to ax bar are given below. First one, x bar of t is equal to e to the power t, t e to the power t, when x bar of 0 is equal to 1, 0. And 2, x bar of t is equal to 0 e to the power t when x bar of 0 is equal to 0, 1. Find first one phi of t and second one system matrix. Two sets of solutions are given. So we have to find state transition matrix and system matrix. Solution. Since u is equal to 0, xn of t, see x of t is same as xn of t. Actually x of t is equal to xn of t plus xf of t. xf of t is 0 because u equals 0. That means x of t is nothing but xn of t. What is xn of t? Phi of t into x bar of 0. So we will take phi of t to be made up of the components ABCD into x bar of 0, where the values of here, instead of where, here the values of A, B, C and D are to be found. This I will call equation 1. First, making use of the first solution. In equation 1 gives, when the initial vector is 1, 0, x of t is what? X of t is e to the power t into t e to the power t. What? E to the power t, t into e to the power t is equal to a, b, c, d. What initial vector? Initial vector is 1, 0. So if you multiply this, you get a, c. This implies a must be what? A must be e to the power t, and b and c must be t into e to the power t. Second one, making use of the second solution. This is second solution. Making use of the second solution in equation 1 gives. Second solution is what? 0 e to the power t is equal to a, b, c, d. What is initial vector? Initial vector is 0, 1. You multiply a into 0 plus b into 1, this is b. C into 0 plus d into 1, this is d. This implies b is equal to 0 and d is equal to e to the power t. Hence what is phi of t? Phi of t is a, b, c, d. What is a? A is e to the power t, B is 0, C is T into e to the power T, D is e to the power T. This is the state transition matrix. So we have found the values of A, B, C, D by making use of solution 1 and solution 2 in equation 1. Sometimes it may not be so straightforward. You may get 4 simultaneous equations in terms of A, B, C, D you have to solve. Here simultaneous equations have not come. There are 4 unknowns A, B, C, D. Depending upon the initial vector, sometimes you may get 4 simultaneous equations. Those 4 simultaneous equations have to be solved to obtain the values of A, B, C and D. Next we have to find what is A. Second part, to find A. We know that phi of t is equal to e to the power at. Differentiating both sides with respect to t. Differentiating both sides with respect to t gives phi dot of t is equal to a into e to the power at. Letting t is equal to 0 gives phi dot of 0 is equal to a into I. This implies a, if you multiply by identity matrix, it remains a only. A is equal to phi dot of 0. That means differentiate this matrix and then put t equal to 0. Differentiate e to the power t. What you get? E to the power t. Differentiate 0, you get 0. Differentiate t into e to the power t. Use product rule. T first function into differential of the second plus second function into differential of the first. E to the power t, if you differentiate, you get e to the power t. This has to be evaluated at t is equal to 0. This matrix represents phi dot of t. You put now t equal to 0. E to the power 0 is 1, this is 0. If you put t equal to 0 here, you get 1, 1. This is the state transition matrix. So it is possible to find the state transition matrix. It is possible to find system matrix A by differentiating the state transition matrix phi of t and then taking the limit t equal to 0. Very important problem, very tricky problem. Next problem. Find the time response. Find the time response of the system defined by the state equation defined by the state equation x1 dot x2 dot is equal to 0 1 minus 3 minus 4 multiplied by column matrix x1 x2 plus 0 1 into u. X bar of 0, initial state vector x bar of 0 is equal to 1 0 and u of t is equal to unit impulse function. This is the problem. Solution. This matrix is A matrix. This matrix is B matrix. Let me write down A matrix. A matrix A is equal to 0, 1, minus 3, minus 4. B matrix equals 0, 1. X bar of 0 is equal to 1, 0. Step 1, to find phi of t. Phi of t is state transition matrix. Recall, phi of t is equal to Laplace inverse of phi of s, where phi of s equals si minus a inverse. We have Si minus A equals, what is I? 1, 0, 1, 1. What is A matrix? A matrix is 0, 1, minus 3, minus 4. So this is S, 0, 0. This is 0. This I is identity matrix having along the diagonal unit values, other elements are 0. 0 S minus 0, 1, minus 3, minus 4. This works out to be S minus 0 is S, 0 minus 1 is minus 1, 0 minus of minus 3 is 3, S plus 4. What is adjoint? Adjoint of Si minus A. Cofactor of S is S plus 4. Cofactor of minus 1 is minus 3. Cofactor of 3 is plus 1. Cofactor of S plus 4 is S. Then take transpose of it. This is the adjoint. First transpose means first row becomes first column. Second row becomes second column. This is the adjoint. Determinant of Si minus A is equal to determinant this into this, S into S plus 4 minus of minus 3. So this is nothing but S square plus 4S plus 3. This is nothing but S plus 1 into S plus 3. Hence, phi of S is equal to adjoint of Si minus A divided by determinant of Si minus A. What is the adjoint? Adjoint is this matrix. So it is S plus 4. Divide each element of this matrix by S plus 1 into S plus 3. That will give you phi of S. S plus 1 into S plus 3. 1 divided by S plus 1 into S plus 3 minus 3 divided by S plus 1 into S plus 3, S divided by S plus 1 into S plus 3. This is phi of S. This I will call first term, this is second element, this is third element, this is fourth element. We have to do partial fraction expansion on these expressions represented by 1, 2, 3 and 4. First one, let S plus 4 divided by S plus 1 into S plus 3 be equal to K1 by S plus 1 plus K2 by S plus 3. This implies K1 into S plus 3 plus K2 into S plus 1 is equal to S plus 4. So put S is equal to minus 1. This implies K1 into minus 1 plus 3 is equal to minus 1 plus 4. This implies K1 equals minus 1 plus 2 is what? Minus 1 plus 2 is 2. 4 minus 1 is 3. 3 by 2. 3 by 2 is equal to 1.5. Next, we put S is equal to minus 3. If you put S is equal to minus 3, this element will be 0. So you get K2 into minus 3 plus 1 is equal to minus 3 plus 4. This implies K2 is equal to 4 minus 3 is 1, 1 minus 3 is minus 2, K2 is minus 0.5. K2 is minus 0.5. So I'll write down the values here. K1 is 1.5, K2 is minus 0.5. Second one, 1 over S plus 1 into S plus 3 is equal to 1 over 3 minus 1 into 1 over S plus 1 minus 1 over S plus 3. I told this note. 1 over S plus A into S plus B will be written as 1 over B minus A multiplied by 1 over S plus A minus 1 over S plus B, provided B is greater than A. So now this is 1 over 3 minus 1 means 0.5. This is 0.5 by S plus 1 minus 0.5 by S plus 3. So I'll just write down here 0.5 comma minus 0.5. Third one, minus 3 by S plus 1 into S plus 3. So it is minus 3 divided by 2 into 1 over S plus 1 minus 1 over S plus 3. So this is minus 1.5 by S plus 1 plus 1.5 divided by S plus 3. The values I will write down. Minus 1.5 plus 1.5. Last one, fourth one. Let S divided by S plus 1 into S plus 3 be equal to K3 divided by S plus 1 plus K4 divided by S plus 3. This implies K3 into S plus 3 plus K4 into S plus 1 is equal to S. Put S is equal to minus 1. This gives what? If you put minus 1, you get 2K3 is equal to minus 1. This implies K3 is equal to minus 0.5. Put S is equal to minus 3. Minus 3 plus 1 is minus 2K4 is equal to minus 3. This implies K4 is equal to 1.5. Hence, phi of S is equal to, first term I will write as 1.5 divided by S plus 1 minus 0.5 divided by S plus 3. Second one I will write as 0.5 by S plus 1 minus 0.5 by S plus 3. Third one I will write as minus 1.5 by S plus 1 plus 1.5 by S plus 3. This is minus 0.5 by S plus 1 plus 1.5 divided by s plus 1, s plus 3. Hence, thus phi of t is equal to Laplace inverse of phi of s. Laplace inverse of phi of s is what? 1.5 e power minus t minus 0.5 e power minus 3t, 0.5 e power minus t minus 0.5 e power minus 3t minus 1.5 e power minus t plus 1.5 e power minus 3t minus 0.5 e power minus t plus 1.5 e power minus 3t. This is the expression for phi of t. I will check. Inverse of this is 1.5 e power t, e power minus t. Inverse of this is minus 0.5 e power minus 3t. Inverse of this is 0.5 e power minus t. Inverse of this is minus 0.5 e power minus 3t. Inverse of this is minus 1.5 e power minus t. Inverse of this is 1.5 e to the power minus 3t. Inverse of this is minus 0.5 e power minus t. Inverse of this is 1.5 e to the power minus 3t. This is the first step to find phi of t. Second step, to find homogeneous solution or natural response or zero input response. Various terminologies are there. What is x bar n of t? Nothing but phi of t into x bar of 0. This is phi of t. If you multiply phi of t by x bar of 0, this element gets multiplied by 1, this element gets multiplied by 0. Multiply this by 1, this by 0 and add. So what you get? You get, this is the answer, 1.5 e power minus t minus 0.5 e power minus 3t. This gets multiplied by 1, this gets multiplied by 0. After multiplying this by 1 and this by 0, you add. So this is what you get, minus 1.5 e power minus t plus 1.5 e power minus 3t. See, in this expression, if you put t equal to 0, phi of 0, this becomes 1, this becomes 0, this becomes 0, this becomes 1. Therefore, phi of 0 is a matrix. In other words, our phi of t is correct. This is the natural response. Next, we will find forced response. Step 3, to find forced response. Forced response, x bar f of t is equal to Laplace inverse of phi of s into b into u of s. Given u of t is equal to impulse function, Laplace transform of impulse is 1. Hence, phi of s into b into u of s. Phi of s is s plus 4 divided by s plus 1 into s plus 3. 1 over s plus 1 into s plus 3 minus 3 by s plus 1 into s plus 3, s divided by s plus 1 into s plus 3, multiplied by b. B is what? 0, 1. U of s is 1. Multiply this into this is 0 plus this into this. So you get 1 over s plus 1 into s plus 3. This into this is 0 plus this into this. So you get s divided by s plus 1 into s plus 3. So using theory of partial fractions, this is nothing but 1 over 3 minus 1. 1 over 3 minus 1 is 0.5. 0.5 into 1 over s plus 1 minus 1 over s plus 3. If you do this partial fractions, you get minus 0.5 divided by s plus 1 plus 1.5 divided by s plus 3. Already partial fraction of this is done. This implies x f of t bar is equal to inverse of this is 0.5 into e power minus t minus 0.5 into e power minus 3t. Inverse of this is minus 0.5 into e power minus t plus 1.5 into e power minus 3t. Step 4, to find total response. Step 4, to find total response. Total response is called time response. X bar of t is equal to xn bar of t plus xf of t bar. So xn of t is what? 1.5 e power minus t minus 0.5 e power minus 3t minus 1.5 e power minus t plus 1.5 e power minus 3t plus x bar f of t is 0.5 e power minus t minus 0.5 e to the power minus 3t minus 0.5 e power minus t plus 1.5 e power minus 3t. Add. If you add these two, what you get? 1.5 plus 0.5 is 2, 2 e power minus t, minus 0.5 minus 0.5 is 1, so you get e power minus 3t, minus 1.5 minus 0.5 is 2, 2 e power minus t, 1.5 plus 1.5 is 3, 3 times e to the power minus 3t. This implies x1 of t is equal to 2 times x1 of t equals 2 times e to the power minus t minus e to the power minus 3t, and x2 of t is equal to 2 times e power minus t plus 3 times e to the power minus 3t. One 0.5 plus 0.5 is 2. 0.5 is minus 1. Minus 0.5 minus 0.5 is minus 1. Minus 1.5 minus 0.5 is, this is minus 2. Minus 0.5 minus 0.2 minus 2. 1.5 is 3. Okay. Please check the calculations. The procedure remains same. By chance, if I have done any mistake here and there, please correct it. But the concept or technique does not change. Hello.
45 minutes. Yeah, 5 minutes.
Please check the solution. Correct. I will give you one problem homework. Homework is find the time response. Find the time response of the system. Find the time response of the system if x1 of t, x2 of t is equal to 0, 1, minus 2, minus 3 multiplied by x, column matrix x1, x2 plus plus 0, 1 into u. Initial state vector x bar of 0 is equal to 1, 1 and u of t is equal to unit step function. Unit step function. So this problem is given to as homework. Here this is A matrix and this is B matrix. U of t is equal to unit step function. Therefore, what is U of s? U of s is 1. The procedure for this problem is same as in the previous problem. So this type of problem, one problem will be asked in your test. So this problem I will not solve. You have to solve it in your own. And if you have any difficulty, please talk to me. Thank you.